Okay, good morning. We're so close to finishing up our final chapter. Today we're going to work on writing rules for geometric sequences and to find the sum of geometric series. If you remember from last week, we were focused on arithmetic sequences in series. So this is just going to be a little bit of a different formula, but the same concept. Okay, so I'm actually going to go ahead and just let's look at number 3 here in this warm-up. Find the sum of the first 20 terms, so sum of the arithmetic sequence. Okay, so here's the arithmetic sequence. So my common difference is 1, and my first term is 4. So to find the sum of a number of terms, you take n times the first term plus the last term, all divided by 2. So what I don't know is my 20th term up here. So I need to find my 20th term. Okay, so the rule is a sub n equals a sub 1 plus n minus 1 times d. So a sub 1 is 4. This is my 20th term they're wanting me to find, and d is 1. So a sub 20 is 4 plus 19, which is a sub 20 is 23. So this will be 20 times 4 plus 23, all divided by 2. And that's going to end up being 10 times 27. So the sum of the first 20 terms is going to be 270. So that was the sum formula for arithmetic. Hopefully you're feeling pretty good about that one. So in the arithmetic sequences and series, they have a common difference that we looked at right there. Okay, something that's going to be different in geometric is they're going to have a ratio that is constant. And we call that a common ratio, and it's going to be denoted with the letter R. So basically, if you take the second, so if you go negative 8 over 4, and then 16 over negative 8, and then negative 32 over 16, are these all reducing to the same thing? So this is negative 2, that's negative 2, this is negative 2, so I would say yes, and I would say R is negative 2. Okay, if you take the next one, you go 9 over 3, negative 27 over 9, you should be able to stop right there because this is 3 and this is negative 3, so those are not the same, so I would say no. So for arithmetic, we did second term minus the first term. For geometric, we're going to do second term divided by the first term. So the rule for a geometric sequence with the first term a sub 1, I don't know why that leaves out. It's kind of weird when I print these as Google Docs and not in Microsoft Word. But the rule is for geometric is a sub n equals your first term times your ratio to the n minus 1. That's very different. Just to remind you, the rule for arithmetic is a sub n is a sub 1 plus n minus 1 times d. So these are very, very different looking rules, okay? So we're going to be focusing on that geometric rule today. So very first problem says write a rule for the nth term. So again, just to kind of write this out, so my rule is going to be a sub 1 times r to the n minus 1. So for arithmetic, we needed to figure out a sub 1 and d. For geometric, we need to figure out a sub 1 and r. So it's easy to see a sub 1. It's just my first number in that list. To figure out r, you're going to do 2 divided by 5. So I'm going to put that in parentheses, and that's going to be my rule for this particular problem. Obviously, that 2/5 can be written as a fraction. It can be written as a decimal. It doesn't really matter, but I would always put that in parentheses. So then it says, then find a sub 8 is what this is supposed to say. So to find the 8th term, I'm going to take 5 to the 2/5 to the 8 minus 1. So it's going to basically be 2/5 or 0.4 to the 7th power. And then you're going to multiply that by that 5, and you're going to get a very small 0.008192 number. And it really kind of makes sense because if you look back at our list, even the fourth term is already down to 0.32 and it's just going to keep getting lower. So that is your 8th term. Okay, so the next example, again, these notes are kind of weird. If you guys can download them in Word, they'd probably come out better. But one term of a geometric sequence is the fourth term is 3. The common ratio is 3. So right here we know R is 3, but what we don't have is a sub 1. A sub 1 is like our big question mark. Okay, so first we're going to use our rule. A sub n is a sub 1 times r to the n minus 1. And we're going to say 3 is a sub 1 times 3 to the 4 minus 1. So 3 is a sub 1 times 3 to the third. So 3 is a sub 1 times 27. And then when I divide both sides by 27, I can write this as 1/9 is my first term. So 1/9 is my first term. So then to write my rule, so now I know this is 1/9. And remember to write a rule. You go a sub n is 1/9 times 3 to the n minus 1. So this is super similar to arithmetic. You just need an a sub 1 and an r instead of an a sub 1 and a d. Okay. Okay, so today we're going to work on finding the sum of a finite geometric series. And I think tomorrow we look at something called infinite, but it's actually an easier formula. So I think you'll find that easy. So the sum formula, this is a little messier than the arithmetic one, is your first term times 1 minus r to the n divided by 1 minus r. And you're just gonna have to be really careful with your calculator on these, okay? So it says, consider the geometric series 4, 2, 1, 1/2. Find the sum of the first 10 terms. So we're trying to find the sum of the first 10 terms. So I'm looking at this formula above. My first term is 4. Okay, and then I'm gonna need r. So to get r, remember I do 2 divided by 4. That's gonna be 1/2. You can do 1/2, or a lot of people like to do the decimals on these. So I'm gonna go 1 minus 0.5 to the 10th, because they want the first 10 terms over 1 minus 0.5. Just mess around with that in your calculator a little bit. I will tell you that it should come out to be on the top like 0.999 and on the bottom 0.5. And then when you divide that out, it's going to be 7.99. That's going to be your sum. All right, let me know if you have questions. I'll post these notes in the homework, and we are just about finished with all of our work for the year. I just want to say thank you to all of you that have worked really hard and kept up with this curriculum. I think it's really going to pay off for you in the long run, and I'm just super proud of you.